So here is another IB Math 11 high level question. So the sum to infinity of a convergent geometric series is equal to the sum to infinity of the squares of its terms. If the first term of the geometric series is 1/4, find its common ratio. Okay, so I think first of all, I'm gonna write the equation Tn equals A, which is the first term, R, which is the common ratio, to the power of n minus 1. And n is the number of terms. And the terms should be, the first term is A, as we said. The second term, you multiply the first term by the common ratio, so you're going to get AR. And then to get the third term, you multiply by R again, and you multiply the second term, so you're going to get AR squared. And that continues. Yeah. Now also, they said the sum to infinity of the squares of its term. So basically, the squares of its term means you got to take each one in here and square them. So I'm going to write this right here. So the first one is A squared. The second one is going to be AR, and you're going to square the term as well. And you're going to square the third term as well. Yeah. The square on the R here, and then you square it. And this continues. So I'm just going to simplify this, and I'm going to get A squared, R squared, because you have to square the A and square the R. And here is going to be, you square the A and you're going to get A squared, and then you square the R squared, and you're going to get R to the 4. And this pattern will continue. So they say in the sum to the infinity, the sum to infinity of a convergent geometric series is equal to the sum to infinity of the squares of its term. So now I'm going to do the sum equation for this. And you know, the equation for the sum of infinite geometric series is S equals the first term A over 1 minus R, providing that R is less than 1. Actually, it's the absolute value of R has to be less than 1. So basically what they're saying, R has to be between -1 and 1. So this is the equation for the infinite geometric series. Now, I'm going to use this equation here. I write the sum that's related to this. So it's going to be, S here is going to be A over 1 minus R, because the first term is A and the common ratio is R. And at the same time, I'm going to use the sum equation to find out the sum of this equation. And therefore, S equals the first term. And the first term here is A squared. And the common ratio, as you see, we're multiplying by R squared to get from one term to another. So this is going to be 1 minus R squared, because the common ratio is R squared. So now they're saying if the first term of the geometric series is 1/4, find the common ratio. So what they're saying to us here in the first statement, that this equals to this, because the sum to infinity of a convergent geometric series is equal to the sum to infinity of the squares of its terms. So this and this are equal. That's what they're saying. And they telling me A is 1/4. So what I'm going to do, I'm going to sub in the A first here. So I'm going to sub it here. A, so 1/4 squared and 1 minus R squared. And you know what? I'm going to simplify this. So I'm going to get 1 over 16 all over 1 minus R squared. This will give me, this is over 1. So it's basically is the same as 1/16 times, and you flip this to 1 over 1 minus R squared, because this is division right here. And when you divide, you change the multiplication and you flip the divisor. And if you're able to bring the 16 down there right away, do that. But a lot of people like to see it done this way. So now this will give me 1 over 16 minus brackets 1 minus r squared. And here, when we substitute the 1/4 for the a, which is the first term, and put 1 minus r on the bottom, then this will end up being 1 over 4 over 1 minus r. Okay. The same thing, the 16 came down with this right here. I just took a shortcut instead of showing you the steps. Okay. Now, since this and this are equal, now I'm going to make them equal and solve. 1 over 4 times 1 minus r equals 1 over this here. So this equals this. That's what they say in the statement here. 16, 1 minus r squared. And now I'm just going to cross multiply that in here and cross multiply that in there. So I'm going to have 16 brackets 1 minus r squared equals 4, 1 minus r. That goes there. And you know what? I'm just going to divide everything by 4 to just make this easier. I'm going to get 4 brackets 1 minus r squared equals, this will cancel. 16 divided by 4 is 4. That's what I got there. And we don't even need the brackets anymore because you don't have anything outside of the brackets anymore. So 1 minus r. And then I'm just going to take this here. I'm going to distribute the 4 inside here. So 4 minus 4r squared equals 1 minus r. I'm going to move everything to one side, equate it to 0. So I'm going to have 0 equals 4r squared minus r minus 3. So basically I move these two to the other side, change the sign of this and change the sign of that, and that's what I get. And now I need to factor this. To factor this factors into, and if you don't know how to factor this, I'll have a video at the end of this session to show you how to factor a trinomial when you have a leading coefficient in front of that squared term. Okay, so this factors into 4r r minus 1 plus 3. And therefore, r equals, from here, it's negative 3/4. That what makes this 0 here. And from here, it's 1. As we said, in the infinite geometric series, r has to be less than 1. Or the absolute value of r has to be less than 1. So we have to reject the 1 here. And negative 3/4 will be the answer for this question. If you enjoyed this video, don't forget to hit that like button, comment if you like, and most importantly, subscribe to my channel. Thanks for watching. Till next time. Bye-bye.